Hey guys, I'm going to go through a review of all of the trig tools that we've been covering. I know we've been reviewing for a little bit, but I just want to make sure that you're prepared for the graded assignment that's going to be pushed out on Wednesday. Okay, so let's go through our key trig tools. So we have our ASTC, which tells us which quadrants which trig functions are positive in. So all are positive in the first quadrant. Sine and its reciprocal cosecant are positive in the second quadrant. All the others will be negative. Tan and its reciprocal cotan are positive in the third quadrant. All the others will be negative. And then cosine and its reciprocal secant will be positive in the fourth quadrant. All the others will be negative. I know I had mentioned in class a little acronym, all students text constantly, all students take calculus, to help you remember that. We also have our unit circle that helps with our quadrantals. So any angle that's located on any of the axes, so 0, 90, 180, 270, 360, etc., or in radians, 0, pi over 2, pi, 3 pi over 2, 2 pi, etc. Okay? So for this, we need to use the whole fact that sine is y over r, cosine is x over r, tan is y over x. And then the reciprocals will clearly just be the flip of that. Okay? From there, we also have our two special right triangles. You got to know which side is across from which angle, otherwise it's going to be screwed up. So that's our 30, 60, 90 and our 45, 45, 90. With these, I use the idea of TOA. Okay, so those are our key trig tools. If I were to say there were 5 of them, 1, 2, 3, 4, 5. Okay, and that's going to help us determine these things. Now, I had gone through the other day during the Zoom also in radians. I think some of us were struggling how things break up in radians. So, for example, this would be pi over 4. This would be 3 pi over 4. This would be 5 pi over 4, 7 pi over 4. Anytime, and I had said this the other day in the Zoom, anytime you have an angle that reduces, first of all, that reduces to a different angle, okay? You basically, someone had said, do you want to use the odds? Any odds that don't reduce to something else. So if your denominator is a 4, that means you have a 45-degree reference angle, and these are the ones that fall in each quadrant. I don't draw this out every time. I just kind of talk to myself and talk through basically the fact that this is 1 pi over 4. 2 pi over 4 reduces to something else. Don't use it. 3 pi over 4 is here, so that'd be the second quadrant for a 45-degree angle. 4 pi over 4 clearly reduces. 5 pi over 4, 6 pi over 4 reduces. 7 pi over 4, 8 pi over 4. You could do the same idea if you have a 3 as a denominator. Your reference angle is 60 degrees. So if I work my way around in terms of 60 degrees, so this would be 1 pi over 3. That'd be the first quadrant angle. This would be 2 pi over 3. 3 pi over 3 would reduce to something else. This would be your 4 pi over 3. These clearly aren't proportionate. Don't judge me. This would be your 5 pi over 3, and then 6 pi over 3 reduces to something else. If your denominator is a 6, that's a 30-degree reference angle. This one gets a little messier here. So I would have 1 pi over 6. 2 pi over 6 reduces to something else. 3 pi over 6 reduces to something else. 4 pi over 6 reduces. 5 pi over 6. 6 pi over 6 reduces. 7 pi over 6. 8 pi over 6 reduces. 9 pi over 6 reduces. 10 pi over 6 reduces. 11 pi over 6. Okay, so hopefully that helps you when you're working with radians. So if I come over here, I'm not going to go through all of these. I'm going to pick a couple to talk through. Okay, I will do a couple in radians here, these couple in degrees, and then a couple equations. I know it says in radians. I'll do a couple in radians, a couple in degrees, and this will be the review video, and then there's practice for you as well. So let's do this first one. So sine 4 pi over 3. Sorry. Okay, so if my denominator is a 3, it's a 60-degree reference angle. 4 pi over 3, that's a little bit bigger than 1 pi, so this is going to put us in quadrant 3. So 60-degree reference angle. Okay, come over here for sine, that's opposite over hypotenuse, so that's root 3 over 2, and in quadrant 3 it would be negative. I'll do number 2. So denominator is 6, so that's a 30-degree reference angle. 11 pi over 6 is just shy of 2 pi, so that would be quadrant 4. So let's come over here. Tan of 30 degrees. Tan is opposite over adjacent. So it would initially be 1 over root 3, but we should rationalize that to root 3 over 3. In quadrant 4, tan should be negative. I'll do number 3. So denominator of 4 would be 45 degrees. 5 pi over 4 is just a little bit bigger than 1 pi, so that's quadrant 3. Now, cosecant is the flip of sine. So if we come over here, 45 degrees, instead of opposite over hypotenuse, it would be hypotenuse over opposite. So root 2, and in quadrant 3, it would be negative. I'm going to do one more here. If you see a denominator of 2 or a whole number value of pi, that means you're doing the unit circle with a quadrantal. So secant goes with cosine. It's the flip of cosine. So instead of x over r, it would be r over x. Pi over 2 goes with this point up here. So the point 0, 1. R is always 1. Okay, and here x is 0, so this would be undefined. Do not leave it as 1 over 0. Tell me that that is undefined. Okay. Oh, sorry, let me go do these ones in degrees here. Sorry that I smashed in. Let me lasso them and move them over a little bit. Shoot. Maybe not. Right, so sine of 210. So 210 is 30 degrees beyond 180. So my reference angle is 30 degrees. That's in quadrant 3. So sine 30 degrees opposite over hypotenuse is 1/2, but quadrant 3 would make it negative. 330 degrees. So that's, you always want to go off of your x-axis. So 330 degrees is 30 degrees away from that. So my reference angle would be 30 degrees, and that's quadrant 4. Tan, opposite over adjacent. So it would be 1 over root 3. So rationalize that, root 3 over 3, but in quadrant 4, it would be negative. Secant of 225. So 225 is 45 degrees beyond 180, and that's in quadrant 3. All right, secant is the flip of cosine. So if we come over here, instead of adjacent over hypotenuse, hypotenuse over adjacent, so root 2, quadrant 3 would be negative. All right, 240, that's 60 degrees beyond the 180 mark. So that's my reference angle, and that's quadrant 3. So cosecant is the flip of sine. So instead of opposite over hypotenuse, it would be hypotenuse over opposite, but then rationalize that to 2 root 3 over 3. In quadrant 3, that would be negative. Sorry, they all came out negative. Didn't mean for that. Okay, so now let's go backwards. I'm going to do 2 in radians and 2 in degrees. Okay, so let's try this first one. So you're going backwards. You're trying to find the angle. Right? Notice that all of these are in radians, these were angles, these are in degrees, these are angles. Here, they didn't give you something in radians or degrees. They gave you the ratio of the side lengths. Okay? So sine theta equals root 3 over 2. So let's come back up here, to our triangle. So to get opposite over hypotenuse, because that's sine, so opposite over hypotenuse, my angle would be 60 degrees. Sorry, let me zoom in. Now, it's negative. What two quadrants is sine negative in? 3 and 4. So we need 2 answers here. Let's do this one in radians. Okay, so 60-degree reference angle means my denominator is a 3. Now, to get to quadrant 3, okay, this would be 1 pi over 3, 2 pi over 3. 3 pi over 3 reduces, 4 pi over 3, and 5 pi over 3. Okay, let's do another one in radians, and then I'll do 2 in degrees. Okay, secant, technically that'd be over 1, so secant theta equals 2. So if we come over here, secant is the flip of cosine. So cosine is adjacent over hypotenuse, so this would be hypotenuse over adjacent. So my reference angle again is 60 degrees. Okay, now secant is positive in quadrants 1 and 4. Okay, so once again, sorry, my denominator is a 3. So in quadrant 1, it would just be 1 pi over 3. To get to quadrant 4, though, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Okay, let's do 2 in degrees. So let's do this one in degrees. Now, you have to think, before this was rationalized, it was 2 over root 3. Okay, so cosecant is the flip of sine. So 2 over root 3. So cosecant is the flip of sine, so opposite over hypotenuse. This would be hypotenuse over opposite. So 60. Why do I keep picking ones with a 60-degree reference angle? Sorry, guys. So 60-degree reference angle. Now, it's positive. Cosecant is positive in quadrants 1 and 2. So 60 degrees would be the quadrant 1, and 120 degrees would be the quadrant 2. Always go from your x-axis. So subtract 60 degrees from 180, and you get 120. Let's do this one in degrees. All right, once again, think about what this was before you rationalized it. So if you have 1 over root 2, that's with your 4590 triangle. So cosine, sorry guys, okay, adjacent over hypotenuse. So my reference angle is 45 degrees. Now it's negative. Cosine's negative in quadrants 2 and 3. So 45 degrees in quadrant 2, take 180, subtract 45, you get 135. And then for quadrant 3, add 45, and you get 225. So I hope that helps. Ooh, let me do one of these order of operations. Sorry, totally forgot about these. So in terms of order of operations, I'm going to do this first guy right here. Let me just jot some of my trig tools real quick so I have them. Okay, so this first piece, remember, I always do this, so I don't lose out on any of these other order of operations here. So cotan of 3 pi over 4. So the denominator is 4, so 45-degree reference angle. 3 pi over 4 is just shy of 1 pi, so excuse me, we're in quadrant 2. So cotan, okay, is the flip of tan. So instead of opposite over adjacent, it would just be adjacent over opposite. In quadrant 2, it would be negative. If you don't have that there, you would lose points. Keep that in mind. You need that. All right. Sine of 7 pi over 4. So 4 for the denominator means 45-degree reference angle. 7 pi over 4 is just shy of 2 pi, which puts us in quadrant 4. Okay, so sine, okay, would be opposite over hypotenuse. So 1 over root 2. I'm going to rationalize that to root 2 over 2. In quadrant 4, that would be negative. Okay, denominator of 3. 60-degree reference angle. 2 pi over 3 is shy of 1 pi, so quadrant 2. So 60 degrees. Cosine is adjacent over hypotenuse, so 1/2 quadrant 2 would be negative. So let's do a little math here. Negative 1 squared is 1 times 4. This would turn into plus root 2 over 2 minus 1/2. I would combine the 4 and the 1/2, so you have 3.5, which is 7/2 plus root 2 over 2. You could technically write it as one fraction because they already have a common denominator. Just throwing that out. All right. I hope this helps, guys. I will recap, I will review all this in the Zoom, but I will have office hours tomorrow to take any questions on any of this and any of the practice files that are listed here for you. I hope everybody's been doing well. Please, please, please reach out at any time with any questions.